Good afternoon, everyone. Thank you for coming. I hope you enjoyed that short video. It's a few years old now, and it showed the third locks being built, and those very large pieces of equipment were the locks for that new canal. But I've updated my presentation today to include all of the progress that's happened since that particular video was made. As you can see up here, we've got some textiles. For those of you who are not familiar with it, these are the molas from the Kuna Indians who live in the San Blas Islands. And my wife, Marianne, would you stand up? My wife is wearing a blouse that she bought 40 years ago when we were visiting the San Blas Islands, and it still fits. Isn't that great? Thank you, Marianne. She bought it secondhand from this little old lady. So it's the real deal. It was worn by a Kuna Indian. Anyway, welcome today. I've got so much to share with you, so let's go ahead and get started. First of all, I wanted to show you my hometown. This is Balboa Canal Zone, and I lived, when I was in high school, I lived diagonally upward to the right of this house. So I had a very nice backyard, as you can see. Beautiful area to grow up in. Now, I've talked to a number of you about books relating to the Panama Canal. The book, you don't have to buy any other book or read any other book, is David McCullough's Path Between the Seas. Pulitzer Prize winning book, magnificent book. It covers the whole story from A to Z, 600 pages. And if you're suffering from insomnia, start reading it about bedtime. And it will serve that purpose as well. Panama Fever is another book that was written from the perspective of the individuals who built the canal, particularly those who were not well paid. They were in dangerous jobs. So it gives a nice balancing perspective to McCullough's book. So in my last presentation that took us up through the French effort to build the Panama Canal, I took you as far as May 4, 1904, and that's where we're going to pick it up today. We're going to talk about constructing the canal, going to talk about the operation of the canal, its transfer from the United States to Panama, as well as the opening of the third locks, and then I'll wrap up with the current threats to the Panama Canal. So let's start off at the very beginning. The first chief engineer who was hired by Teddy Roosevelt to build the canal was a railroad man by the name of John Wallace, and he was a strong advocate of a sea-level canal. Very, very different than the canal that we ended up with. And the commission that was overseeing the building of the Panama Canal said, you need to get some momentum going. Make the dirt fly. Let's excavate as much as we can, as quickly as we can. He was very well paid, second only to the President of the United States in terms of a salary from the federal government. But there was still a problem with diseases. And people were just scared to death of yellow fever. I described it in its horrible detail in my last presentation. But people were quitting. They couldn't keep anyone there because the problem had not been solved yet. And in fact, it didn't help things at all when it was discovered that Wallace had shipped 2 metal coffins to the canal zone for himself and his wife. When that word got out, I think everybody was heading for the next boat. So he realized he was way over his head. And so he started floating his resume with various railroad companies in the United States. Secretary of War Taft heard about it and fired him. Could not have the head man looking for another job. That's a terrible example. So the next person who was hired was John Stevens, also a railroad man. Railroads were the largest construction projects in the United States at that point in time. So they were looking for somebody who had expertise in running large projects. So John Stevens, and by the way, it's not very well known that John Stevens was Paul Newman's grandfather. It's not well known because it's not true. So forget that, okay? So John being a railroad man, he saw the remains of the Panama Railroad and realized that this would be a wonderful asset for the new canal. And so he rebuilt a railroad, and at the ports at either end built piers and warehouses, communities for the workers. In effect, he was focusing on the infrastructure. That's a term we use a lot these days. They didn't use it back then. But the basic foundational kinds of things that would support the building of the canal. Very importantly, he convinced Roosevelt that a sea level canal was an absolute disaster. It was not the way to go. Needed to be a lock canal. Authorized extensive sanitation and mosquito control programs. He realized that was a problem that had to be beaten. Well, fortunately for him and for this canal effort, just a few years before, in Havana, Dr. Walter Reed and his team of Army medical doctors had figured out that yellow fever was transmitted by a mosquito, the Aedes aegypti. And if they could disrupt the life cycle of that mosquito, they could eliminate yellow fever. And therefore, he set out, he gave to the man in the upper left-hand corner there with his arms folded, he gave him the job of eradicating yellow fever in Havana. And within a year, it was done because the larval breeding grounds of the mosquito were disrupted. And that man, William Crawford Gorgas, became the chief sanitary officer of this new construction effort. There could not have been a better man for the job. He was technically expert. He was also a very wonderful person, very friendly, and hardworking. He was out there on the job from daylight to sundown. Drained the swamps and ponds, laid petroleum products on top of whatever water was there, again, to disrupt the life cycle of the mosquitoes. Sent fumigation brigades into every home at the Panama City end of the canal and Colon and everywhere in between to fumigate out the various possible breeding places of mosquitoes within homes. Introduced screens for residences, as well as screens that were able to keep the people who had been infected, I should say, by yellow fever, keep them away from mosquitoes who would bite them and then transmit the disease. So the isolation wards had screening. And 2 years, just 2 years after he began this effort, he called his medical team to the basement of the hospital that eventually would have his name, Gorgas Hospital, and said, looking at a corpse, he said, "This will be the last person we see who dies of yellow fever." And it was the last person. So he did his job. Well, Teddy Roosevelt, if you're at all familiar with him, wherever there's something going on, he wants to be there. And in 1906, he got onto the SS Louisiana, I think a battleship, and sailed on down to Colon, the first president to leave the United States while in office. And he could not wait to get out there and see what was going on. It was the rainy season. He picked the worst time of the year to go. All of the commission members who would come down to inspect things, they'd always come in the dry season when it's very, very nice and temperate and so forth. He came down in the worst time of the year. And when his aide came looking for him on the battleship to take him ashore, he found out that Teddy was already there on the land, talking to the common workers, getting an on-the-ground feel for how things were going. How did they feel about things? And you know, he was almost like a big boy. Wherever there were toys to play with, he was going to play with them. And so here he is on one of the Bucyrus steam shovels. Those monsters, there were 70 of them out of 102 steam shovels in the construction effort. Each one of them could dig out 8 tons of soil. This was so much more powerful than anything that de Lesseps and the French effort had used. 8 tons of soil with each grab of the bucket. And so there were a lot of technological advances that had occurred that were now being used to advance the construction of the canal. Now, one of the Q&As after my last presentation, somebody asked, where did all of the workers come from? Well, many of them came from the eastern, northern seaboard of the United States and from Europe as well, generally speaking for the higher level jobs, but the real manpower came from Jamaica and Barbados. 24,000 workers. And that was such a wonderful escape from poverty for them. And again, those books that I mentioned at the front end, you'll read about how this was such a great opportunity for the people of these impoverished islands to be able to get ahead in life. But when they came to the canal, to Panama, they were given the absolute worst jobs, the most dirty, the most dangerous jobs of all. And in fact, these pictures here show workers working with explosives, carrying boxes of explosives, drilling down in the lower right-hand corner there. And the mortality rate was very, very high, as you might imagine, for these individuals. Segregation was alive and well in Panama at that point in time. More explosives were used in the excavation of the Panama Canal than all of the wars that had taken place up to that point in time. Well, John Stevens, having made wonderful strides in establishing the infrastructure, realized, hey, I'm a railroad man. I'm not a canal builder. I think I will resign. And he, by the way, he went on to build the Trans-Siberian Railway. So he wasn't done doing things. But Teddy Roosevelt, who had thought that he had hired this man to take the job to completion, was very unhappy. Teddy was not a happy camper. And so he decided he was going to hire somebody who would stay on the job. And the person he chose was this individual right here. George Washington Goethals was the third chief engineer. And he told Goethals, there are only two circumstances under which you're going to be coming back to the United States. You'll either come back in a casket, or you'll come back after having completed the canal. Now, since he was an officer in the Army Corps of Engineers, Teddy could tell him to do that. And so that's what he did. And he became the czar of the canal construction effort. 2 weeks after he came on the job, the excavation workers went on strike. They were the highest paid workers. They wanted a 20% increase. Goethals fired them all. It brought construction to a total standstill, but it sent the message, I'm in charge here. And those people went home on the next boat. So he became the czar. He was a very serious man. I mean, that's his typical facial expression. The fellow on his immediate right, though, is our friend Gorgas, sort of a jovial personality. I understand from some things I read that they were like oil and water working together, but at any rate, they were able to forge a companionship. And the man immediately to Goethal's left was Gaillard, and I'll be talking more about him in just a moment. So, the first thing that he did as the new chief engineer was to organize the work. And in the Atlantic Division, that consisted primarily of building a massive breakwater, which we will sail through in a couple of days as we exit the canal and go through Limon Bay. We'll see that breakwater. 3 locks at Gatun Locks, and also building the Gatun Dam, which needed to impound the waters of the Chagres River to form Gatun Lake. So that was a very important and extensive amount of work that needed to be done on the Atlantic side. The Pacific side, again, building a breakwater, and you're going to be driving over it because that breakwater is the causeway that we will be driving on tomorrow, I guess. And in addition, 3 locks on that side of the isthmus as well. In this case, 2 Miraflores locks and 1 Pedro Miguel lock. And so that was a lot of work as well that needed to be done. But the Central Division had the biggest job of all. They had to carve a channel through the Continental Divide to be able to create a lake that was 85 feet above sea level at that point in time. And that was the most tough job of all. And it was given to this man, Major David Dubose Gaillard. And the cut is named after him. Actually, Panama calls it Culebra Cut nowadays, but in paying homage to this wonderful man, I continue to call it Gaillard Cut. And it was his drive, his determination, his ability to go forward in the face of major difficulties, that was really one of the major keys to the success of building the Panama Canal. Unfortunately, he died of a brain tumor in Johns Hopkins Hospital 6 months before the canal opened. But his job was primarily done at that point in time. And again, it entailed cutting 8 miles through the Continental Divide. There's one of those Bucyrus shovels I was just talking about. Now, let's process this graphic for just a minute. The brown portion right there in the center, as you can see in the lower right-hand corner, was the French excavation effort. And it was a fairly considerable contribution that they made. 19 million cubic yards were removed. And the idea was that the canal at that point would be approximately 670 feet wide. That was the width of this cut through the mountains. That was the idea. But the problem was that the soil in that part of the mountains was a very complex composition. A lot of different kinds of rocks and clay. And clay, when wet, slides down. And so they, instead of having a cut 670 feet wide, it ended up being 3 times wider because the soil had not reached its angle of repose. In other words, where it will sit and stay sitting. And even today, that angle of repose has not been met yet. And that's for that reason you're going to see dredging going on in the Gaillard Cut as we pass through. You'll see dredging going on, still going on. So, the landslides occurred over and over and over again. It must have taken a huge amount of courage and intellectual strength to be able to continue to persist in the face of the difficulty of the ongoing landslides. 2.5 years were added to the schedule of the canal because of that soil that kept sliding down into the cut. A huge amount of spoil, that's what they called it, was removed, equivalent to dirt 10 feet by 55 feet from New York City to San Francisco. That is a lot of dirt. But they got to be so good at excavating that every day they were able to remove approximately 120 Olympic pool. The quantities that could fit into 120 Olympic pools, they were able to remove every day. So they got really good at excavating. But another part of the challenge was, what do you do with the spoil? How do you get it out of there and get it somewhere else? They were able to, again, fix up the Panama Railroad line, became a very solid source of support for all of this effort. 160 loaded trains every day, every 1.5 minutes. And so what they would do is they'd have these long trains, 20 open air cars. They'd throw the dirt on top of it and run it out to the end of the line, wherever that happened to be, and it could be just about anywhere, because there weren't environmental impact statements back in those days. So they would take the end of the line out into the jungle, and then with this Lidgerwood dumping system, you see a metal sort of triangular here, it would be pulled by a cable towards the front, and as it was pulled at an angle, it would dump the dirt off to the side. They could unload a 20-car train in 10 minutes. These people were just so expert at improvising. And then another train would come along with a blade and push the dirt away from the tracks. And after a while, they'd just pick up whole sections of tracks, move them over next to where they used to be, and repeat the process over and over and over again. So they got really good at excavating and moving the spoil. Now, a lot of the spoil ended up here, Gatun Dam. At that point in time that it was built, this is it right here, an earthen dam. It looks like just dirt and grass right now. Massive. It was the largest earthen dam in the history of the world at that point in time. Off to the right there, you can see Gatun Locks. Way off in the distance is the Caribbean entrance to the Panama Canal. And then on the left, in the lower left-hand corner, is the spillway. And I'll be talking more about the spillway, but there needs to be a way to let the excess water in the lake run off, and that's what it does. And the Chagres River continues below the spillway and then goes off into the Atlantic Ocean. Construction of the locks. By the way, at this point in time, the Wright brothers were just learning how to fly. Buildings were generally not made of concrete, large buildings. It was the very beginning of the age of using concrete for major construction. Electricity wasn't being used in large cities, except perhaps at the very beginning stages. Each lock chamber, 110 feet wide, 1,050 feet long. When the most massive construction engineering project in the history of the world up to that point in time. Somebody was asking me the other day, how did they get to those dimensions? There was, I recall, a commission put together by the Army Corps of Engineers, the Department of Navy, various commercial interests. But they figured out that they would need these dimensions, and they built them, the locks, to those dimensions. And those dimensions were sufficient for the next 80 years, if you can imagine that. They built them much larger than they needed them at that point in time, but they built them large enough to accommodate the growth of ships for 8 decades thereafter. Massive construction. Boggles the mind. The gates are a wonderful engineering innovation. As you can see, they're sort of honeycombed, and being honeycombed, they don't exactly float, but they're very light in the water, and so it doesn't take much electricity to open or close them. And in fact, each gate only takes the equivalent of 2 25 horsepower motors. Now, how many people have a riding mower at home? Can I see a show of hands? Any? Okay, a few of you do. You've got, your riding mower has about a 25 horsepower motor. So the equivalent of 2 riding mower motors for each gate. As you can see, the dimensions were massive. The differences in the height between 42 and 87 feet tall, that is because the tides from the 2 oceans vary significantly. The Caribbean, Atlantic, not nearly as much as the variation of the tides in the Pacific. And therefore, the first gate that we come to at Miraflores Locks is the tallest gate because that has the greatest tidal fluctuation. Oh, by the way, before I forget, these are miter gates that would swing together and lock like that. And that particular design was originally envisioned by the well-known engineer, architect, artist by the name of Leonardo da Vinci. Well, the excavations continued. The steam shovels finally met in Gilliard Cut. And what a wonderful day that was for everyone. The first ship went through August 15, 1914. And you would think that after this huge effort, all the world watching, that it would be in the headlines of every newspaper in the world. Well, this happened to be 2 weeks after the commencement of the First World War. And so in the New York Times, it was buried on about page 20. So it didn't get very much publicity at all, not nearly as much as you would have expected. You can see the costs there, $257 billion in today's dollars. 5,609 individuals died. I was talking about the French canal building effort. 25,000 died for that effort, and it was ultimately unsuccessful. And so because of the advances in controlling diseases and so forth, and hospitals that were very, very effective, the mortality rate was much lower than for the French. So let's talk about the canal operations. Pilots. The last time I came through on a ship this size, there were 3 pilots who got on board. They have full responsibility for navigation of the ship during Panama Canal transits. One is always on the bridge, and then the other 2 are on either side, just sort of, and they're always in contact with each other. And of course, the master of our vessel, the captain, is right there with them. But when we're in the canal after the pilot comes on board, he is the master of the ship at that point. They need to have master's licenses. In other words, they must have been captains of deep water vessels themselves for at least 2 years. They have to take extensive exams, simulation exercises, go through a 3-year training program, and eventually they get certified as pilots. And as they work their way up, it's a very lucrative job. The most senior pilots get as much as $450,000 a year. So here's our canal. And by the way, it does not run east-west, folks. It's north-south. We are going on a northern transit. Here's the north, here's the south. Southbound vessels, northbound vessels. And as I indicated earlier, there are locks at either end of the canal. Here are Miraflores locks, Pedro Miguel locks, Gatun locks, upper left-hand corner. And as you can see at the graphic at the bottom there, we take those steps up to approximately 85 feet above sea level. By the way, it is now 86.5 feet because of the third locks, but perhaps not all of the graphics indicate that. And here we are, and this is just a really quick lock system for dummies kind of thing. Please don't take it personally. The ship will enter, as you look at the middle of the top there, they'll enter the first lock. The second lock will drain half of its contents. We're in level, the third box now, and raise the ship that's in the first lock up. It'll sail into the second lock. The process is repeated until eventually the ship is at the level of Gatun Lake. And that process is, again, when you go across the lake and you descend again, you have to go all the way down through a 3-step process again. A lot of water is lost. This is very significant. 52 million gallons are released into the ocean with each transit. That is enough for many cities. And here we are, Gatun locks. That's at the other end of the canal. We'll be seeing those, hopefully, I don't know, you really don't know when you're going to be at a particular place in the canal. I've exited Gatun locks at 5 or 6 in the evening. We should be there in the daylight, unless major problems occur. As you can see, we're at sea level here in the lower right, and then the first, and then the second step, and then the third step. And off in the distance there is Gatun Lake. The mules. Those of you who are familiar with the canals that were built in various parts of the world in the 18th century know that in many cases, mules pulled the barges through the canals. So they called these electric locomotives made by Mitsubishi mules. They're fairly expensive. And the last time, again, I went through the canal on a ship this size, there were 3 mules on each side of the ship. Each of the mules has 2 lines tied to the ship. The purpose of the mules is not to propel the ship through the locks. The ship is under its own power. It is to center the ship in the middle of the locks, so they keep tension on either side to keep the ship exactly in the center, so it won't be banging against either side or run into the gate in front or behind. Now, I had a question the other day about what does it cost for a ship like this to go through the canal. This is something put out by the Panama Canal Authority. You can't read the fine print, don't worry about it. But I think what it really said, there are all kinds of ships that go through the canal. Cruise ships, container ships, liquid petroleum, gasoline ships, on and on and on. And each one of them has its own specific fare structure. So, for the Zonda, cruise ships, the fare structure is based on the number of berths. In other words, beds on the ship. And it's not filled beds, but beds. An empty bed costs as much as one that's occupied. So on this ship, 1,432 passenger capacity, 615 crew, total of 2,047 berths, $138 per berth. And by the way, this this number 138, that's the latest that I was able to find. It might have changed by now. Panama is forever raising the tariffs because the canal is a cash cow for their budget. 40% of the budget of the government of Panama comes from the canal revenues. So, at any rate, you do the math, 282,846. And that's only about half of what this ship will pay. And why is that? Because there is a major fee associated with reserving a particular transit entrance time. And I would say, and again, that's not a figure that's readily available, but I dare say it's probably at least $200,000. So we're talking about a little bit south of $500,000 for this ship to go through. And so thank you for paying for that. Because otherwise we wouldn't go through. That's it, a part of what you have paid. Oh, and by the way, the largest fee for a cruise ship, the Norwegian Bliss went through not too long ago, and that's one of the larger ships, not one of the really large cruise ships, but I think about 4,000, something like that. They paid $900,000 to go through. So that's the high end right now for cruise ships going through the canal. Okay, leaving operations of the canal and moving to more current events here. This is my high school, Balboa High School. The picture was taken my senior year, November 22, 1963. It's at half-mast. That was the day that John F. Kennedy died. And so there was one flagpole in front of my high school. Just less than 2 months after that picture was taken, high school students from Panama, and the high school students are generally the most revolutionary-minded, the most patriotic of members of Panamanian society. And they marched, this is right in front of where that flagpole is, just about 100 feet away. They marched in, they wanted to raise their flag, lower the American flag, raise their flag. The students in my high school class, as well as the local police, prevented them from doing that. They marched back into Panama. Along the way, this flag, which apparently had some historical significance, was damaged. They marched back into Panama, and at that point in time, an international crisis developed called the Panama Canal Flag Riots. As you can see, it was a horrible thing. 28 Panamanians were killed, 4 U.S. soldiers. The border between Panama City and Balboa, between Colon and the American territory on the Atlantic side, was cordoned off by the military. We had tanks going down the streets within a block of my house, and diplomatic relations were broken, and it was just a total rupture of relationships between the United States and Panama. Fortunately, things were mended over a period of time, and the main thing that eventually mended that relationship were these treaties that were signed in 1977. Now, there were 2 of them, and this is important for you to understand. The second treaty would not have been signed if the first treaty would not have been created and approved by the United States Congress if the first treaty had not been approved and signed before the second one. First of all, a neutrality treaty. U.S. retained the right to defend the canal from any threat, etc., and so forth. In other words, it's a carte blanche to go into the canal zone in order to protect the canal at any point in time that the United States, in its own decision, felt like the canal's operations were being threatened. And then, after that neutrality treaty had been signed and approved and signed, by the way, that's Carter on the left-hand side, and Omar Torrijos, who is the president of Panama, on the right. The second treaty is what the Panamanians really wanted. At midnight, the last day of the millennium, they took over full control of the canal operations. Between 1977 and 2000, there had been a gradual sharing of responsibilities, and more Panama took over the operations of the canal. So it wasn't one of these, they're doing nothing and all of a sudden they're doing everything. This was just sort of the very end of a process that began in 1977. By the way, that sinister-looking fellow to the left of the flag with sunglasses on, anyone recognize him? Noriega, exactly. And I'll be talking about him in my presentation in another week or so on the United States and the Caribbean and Operation Just Cause. But let's continue on. The canal was transferred, and that's Carter in the middle there, and I believe to his right was the president of Panama at that point in time. So let's talk about the third locks. 2007 to 2016, why did they need to be built? Well, first of all, why third locks? The original canal had 2 sets of locks side by side. So those are the first 2 locks. And then a third lock was built for the larger ships. And why did it need to be built? As you can see, beginning in 1998, ships got too large to go through, began to get too large to go through the canal. And Panama was losing a lot of its market share in terms of marine traffic. These are container ships, and you're going to see a lot of them. And the capacity of a container ship is measured in TEU, 20-foot equivalent units. So each one of these containers that we see on the docks, that's 1 TEU. And so the capacity of a ship is how many of those containers can it transport. By the way, there are other sizes of the container, and they're not all 20-foot equivalent unit, but generally speaking, that's what they are referred to as. So the Panamax vessels, the vessels that had maxed out, the largest ones that could pass through the original canal, they had gotten so big, it was like putting a size 10 foot into a size 9.5 shoe. It was really a tight squeeze. And so the third locks had to be a lot bigger to accommodate these larger ships. So in terms of the length, 1,200-foot ships with the new canal 964. In terms of the width of the ship or the beam, 160 versus 105. In terms of the draft, in other words, fully loaded, how deep does the ship sit in the water? 49 versus 39 feet. The main thing is the Panamax ships could only carry 4,500 TEUs. The post-Panamax, in other words, the ones using the third locks, almost 3 times as much. So here we are again back to this graphic we looked at a little bit earlier. What did they need to do in order to create the third locks? Well, they had to deepen the approaches to the canal at either end of the canal. These ships had a lower draft, so they had to be, the approaches had to be deepened. And then at each end of the canal, there needed to be a new set of locks. And so let's look in the lower left-hand corner here. On the upper part there, you'll see the old canal, the heavy red line. 2 locks at Miraflores locks, 1 lock at Pedro Miguel. Below that, the dotted line, are the 3 third locks. So they are parallel to each other. Up to that point in time, they share the channel. Up to right about there. And then after that point in time, they share the channel again as they go through Gaillard Cut, past Gamboa, onto the Gatun Lake, and then they get to the other end, and they separate at that point in time. And that's the picture a little bit above this other one. Here are the original locks on the left. Again, 2 parallel, 3 sets of locks with 2 side by side, and then to the right are the 3 locks, the large locks built for these larger ships. And so we won't be able to see those very well. We'll be able to see the entrance here. We'll be able to see the entrance there, but you won't be able to really see ships going through those locks because, for the most part, there's land between the 2 channels at that point in time. But they have to go through the same process of raising up to the Gatun Lake, cross it, and going down again. And as I mentioned, the original height of the surface of Gatun Lake was 85 feet. They had to add 1.5 feet to accommodate these larger ships. So right now, it's instead of 85 feet above sea level, it's 86.5. So here are the dimensions. You can just take a moment to compare the width of the Third Lock Canal to the original canal, significantly larger so that they could accommodate significantly larger ships. The locks are a totally different technology. Here we are more than 100 years later, so you would think that there would be new ways of operating the locks, and in fact there are. There are water retention chambers to the left, or to the side there, of each one of those locks. And this new technology of water retention, they're able to save 3/5 of the water that would normally be vented into the ocean by using those water basins. Now, another thing that's different are the gates. In that video at the very beginning, before I started my presentation, you saw these being shipped through the canal. These are the gates. They are not miter gates. They are sliding gates. So it's a totally different way to operate. And each one gate rather than two gates working in tandem with each other. There are no mules. How are they kept centered in the middle of these large locks? By tugboats. A tugboat at the front and a tugboat at the very back. Again, those ships are under their own propulsion, but the tension on the lines they're held in place by the lines that attach to the tugboats at the front and at the back. Well, the locks finally opened, 2016, June 26. As you can see, the number of transit increased a little bit. We're between 35 and 40 transits per day. It varies significantly. But because they charge so much more for those boats, the amount of the tolls that are derived from the canal increased significantly. And so here's a picture of the Caribbean entrance, the Atlantic entrance. On the right, we've got our regular old original locks, and those are the ones that we'll be going through. And then on the left, not very far away, but out of sight at that point in time, are the third locks, each one of them having its own 3 water retention basins. And these are the Cocoli locks on the Pacific side. Again, the 3 basins. Off in the distance there, you can see the Bridge of the Americas. So that's the entrance, the Pacific entrance to the Panama Canal. And I love this picture, so I thought I'd share it with you. I just got it a few weeks ago. It shows you the location of the different locks on the Pacific side. Now, we are going to be, after the third lock ships pass through, they will be 86.5 feet above us over here. So we will be able to see them up above us on our left as we enter Miraflores and Pedro Miguel locks. And then at the end here, out of the picture, we're going to share the channel through Gaillard Cut. Now, can the monstrosities of the sea go through the canal? That's a question that I've heard a number of times. Well, let's take a look at it. Those were the largest ships that could go through the canal. I take that back. Those are the size of the ships that can go through the third locks now, post-Panamax. The Anthem of the Seas. So, you would think that they can go through. But there's a little bridge. There's a problem. The Bridge of the Americas that was built back in 1962 is too low. And so the Anthem of the Seas cannot do it. Now, some of the larger ships can. I mentioned the Norwegian Bliss, but it doesn't have a height draft that is higher than 201 feet. So it can pass underneath. Okay, we're going to get into a few risks here, and then I'll wrap it up. Lack of rainfall. Okay, first of all, I teach risk management at Georgetown University, and that number on a scale of 1 to 10, that's the combination of probability and impact of something bad happening. This is a picture of the spillway at Gatun Dam at the sort of towards the end of the rainy season. You know, they've got to let the water run off, or otherwise it'll run over the side of the bathtub. So they open the spillway gates, and it vents into the Chagres River out into the ocean. Take a moment to read that. December is the beginning of the dry season, usually. Apparently the dry season began a little earlier last year. And then just a few weeks ago, less than 2 months ago, in the Sea Trade Maritime News, they indicated for the third time they are reducing the acceptable draft of ships. In other words, there's not enough water up to 86.5 feet. It's down from that. And so ships entering after 13 March of this year, about a month ago, they can only have 47 feet of draft. They were promised 49 feet of draft. So what? What's the big deal? 2 feet. It's a very big deal because ships load to capacity. And if their draft is lower than 47 feet after 13 March, they've got to offload some of their cargo and ship it across the isthmus on the railroad perhaps and reload it up again, if in fact they can. Some cargoes are not so easily moved around. This is a major problem. It's only going to get worse. They need to develop new reservoirs so that Gatun Lake can be replenished to keep it high enough so that they don't have to disrupt the shipping industry. Okay, threat number 2, alternative routes. And that was an 8, by the way. That was very, very high risk. This one's 7, not quite as much. Here we've got Hong Kong, 11,000 nautical miles to the eastern seaboard of the United States each way, but going through the Suez Canal is more time-consuming. And so that's a major advantage for the Panama Canal, except for ships who want to sail fully loaded. And if they have this draft problem in the canal, ships may begin to go west rather than east from the Orient. Now, you've heard about the Nicaragua option for a while. Just forget about it. It's not going to happen. The Chinese billionaire who's going to bankroll that, apparently he lost his shirt in some of the financial problems going on in China. The political stability in Nicaragua is non-existent. Ortega is under a major threat. That's just not going to happen, so let's not worry about that. But there is another route that poses a very, very high threat for the use of the Panama Canal. The first large container ship through the Arctic Ocean last year. Why is that? Because of climate change. And the ice isn't as thick, it melts earlier, and so ships are going through the Northwest, or will be able to go through the Northwest Passage in increasing numbers in the future. And it's a much shorter route from the Orient over by the North Pole as opposed to going down to the Panama Canal. And finally, larger ships. Even larger ships now are being built that can't be accommodated by the third locks. I don't know if you remember, but the third lock ships could carry 12,000 TEUs containers. These large ships that are being built now can carry 18,000. The third locks are not large enough.